I would like to acknowledge the Bidjigal people of the Eora Nation, the traditional custodians of this land, and I wish to pay my respects to elders past, present, and emerging. So just about me, I started this project photographing bees and other insects in October 2025. I've been photographing wild birds since 2019, but I'm new to studying invertebrates and macrophotography. So it's been a crazy journey. Crazy, crazy journey. So all the invertebrates that I photographed with decent detail, which includes pretty much most of the photos I've included in the presentation tonight, have been uploaded to iNaturalist, which is a citizen science platform, and that's really good because it basically crowdsources experts in the field to help us like less educated people or less experienced people with identifying what's in the world around us. Because if we don't know what's around us, then we don't know how to save them or how to help them. So as part of that, when I started this project, I think we were at 700 total species recorded in Oatley Park and Kiln Bay. And it is currently at, I think, 1,100. I got that up to about 1,050, I think. And someone recently came in with some plant IDs. So that is plants, fungi, uh, insects, spiders, mites, fish, crabs, birds, and things like that. That is a lot of different species just found within a very small area. And I think it's amazing because it's in the middle of suburbia. There's houses all over around nearby, like across the river, around the outskirts of the park, and it is used by quite a few people. Despite that, there is still so much biodiversity that we didn't know about. So as part of that, here is some of the wasps I found in Oakley Park. Some, because I couldn't fit them all. Some of you might have seen my bee collage. Bees are not in this one. The bees are on a separate one. So on this, we've got Apodia, those are on the top left. Those are predatory wasps, and they target different species. Like some of them target cockroaches, some of them target flies, some of them target other insects. Some of them target spiders as well. So we've got quite a variety of those. The rest of the wasps are different parasitoids. So they target either the eggs or the larvae or the adults of other invertebrates. And their eggs use those invertebrates as resource to grow up and become an adult. So they're really important for sort of keeping control over like pest species that some people find in their gardens. And it's because if you don't have enough of these other insects, those numbers can get out of control. Because for when these guys are in the ecosystem, if there's a lot of prey insects, they boom in number, and that helps to keep the numbers down. So there's a lot here, but I haven't included any of the ants. So I am actually not very good at photographing ants and noticing because with my macro lens, my hand shake too much. And ants are very low to the ground, very small sometimes. So some of these ants are about as small as 2 millimeters, and they grow as big as about 20 millimeters for some of those bull ants. So some very interesting ones. This long one here is an interesting one because that's an ant hunter. It specializes in hunting other ants for food. So that was pretty cool. Not often, but just finding that was pretty interesting. So if I found 40 without trying too hard, I'm sure that with a bit of effort, I'll eventually get to finding more. It's just quite difficult to tell them apart by eye sometimes without some practice. So we'll see. And here are the bees that I found. Well, I can't get all of these identified as species. I think the last count was about 30 identified as species based off physical characteristics. And it's a nice variety, but in Australia, there's approximately 2,000 native, there's an estimated 2,000 Australian native bee species. And so there's still a lot to find. I'm sure that there will be more. When I started, I didn't know like the right settings for what bees were, what times to find them in, what plants they liked the best, like how to find them, where they lived, all that sort of stuff within the park. And so I think that I'll have a lot more luck this year. But still, that's a lot of different bees. So even if some of these maybe, I think there's definitely one double counted here. But I fixed that idea. So I'm sure with some more time and effort, I'll be able to sort of find information about these guys. But it's kind of difficult because I don't capture any of my insects that I've photographed. So all of this was handheld, no flash, just natural sunlight, and no net. For a lot of macro photographers, some people anyway, they have like nets and like a little ice chest to sort of cool them down so you can get an easier photo. But all of these I photographed like just mostly luck and skill. So out of this lot, we've got 20 of the Coletidae family, 14 of the Halictidae family, 10 of the Aphidae family, and 4 of the Megachilidae family. Those words don't mean much at the moment, but I'll get to those. I'll explain more because understanding the bees and their history helps you to understand why the different bees like different plants and where they like to like nest and sort of what bees you can expect to find around you based off those. So bees are solitary, they evolved from solitary wasps of the family Probodidae. Sorry. Related to the family Probodidae, probably. It's DNA analysis pretty difficult. We do know that, however, that what is it? Based off how sort of the evolutionary trees work, all the bees are still part of the wasp family, but not all wasps are part of the bee family. And so because of that sort of nesting within it, they share a lot of characteristics and features and behaviors that you find in the wasps. And that makes it very difficult for people who sort of are unfamiliar with all the different types of bees we have. They're basically wasps that became vegetarian. So while the wasps of their related family, they're all predatory bees in that they will hunt for like prey and stop it in their burrows and lay an egg on it. And then when the egg hatches, the larvae uses the prey that's inside the burrow to eat and grow up. The bees replace that with pollen and nectar, which when they evolved was very plentiful because not that many other insects are actually using it in such a way. And as a result, they are very important because our plants sort of evolved it to sort of compete for more bee attention. And the bees also evolved to match that. So there's a bit of an arms race to try and attract as many bees as possible without sort of spending as much energy for it. But sometimes it can be quite difficult to recognize them because there's a lot of bees that mimic wasps, some bees that mimic other bees, and some flies that mimic wasps as well. So everyone's trying to play pretend because most sort of predators know that wasps sting and they hurt a lot. So it's better not to touch them. And so the sort of all these bees and wasps and flies have sort of evolved to look similar to stop being eaten. Can completely understand that. So here we can see that bee diagram, but I've now labeled it with the different families. So we've got the Halipidae, which are short-tongued bees. They're often known as whip bees. They tend to either burrow into the ground or some of them burrow into dead wood. The Apidae are the long-tongued bees, and included within those are things like the carpenter bees, the reed bees, the banded Amagilla bees, the pettiberry, as well as our native stingless bees, which produce honey. And the blue ones on the top right, those ones are just underneath the Apidae name. There's 3 of them. Those are cuckoo bees. Interestingly, in Australia, we don't have very many cuckoo bees. It's probably due to how bees evolved, but in Australia, what is it? We've got way less cuckoo bees as a percentage of everything, as in bees that take advantage of other bees' burrows to lay their eggs compared to other parts of the world. And that's probably because Australia was quite isolated for quite a while, and I'll explain that soon. The Megachilidae are the leaf cutter and resin bees, and I find them really cute, but unfortunately I couldn't find very many of them in the park. It's probably due to how the park is sort of set up and how we don't have very many soft-leaved plants in the immediate vicinity of the park, but we'll see. And then at the bottom is the Collettidae, which is a very old family group that's lived in Australia for a very long time. And as part of that are the Halaene, and those ones are the most wasp-like looking, but they're a pretty young family. So even though they look primitive, they're not primitive. They've just evolved to look more like wasps, probably because in Australia they don't need to worry about sort of like sort of gathering as much, and it actually costs them less energy to be have less hair. Could be. Okay, so this is a family tree. I took this. There's been a lot of DNA analysis of the sort of like native bee, different native bees around the world and how they sort of all nest together, because it's important in sort of understanding how sort of they came about. And based off that information that it was Almeida et al. Haven't put a reference, but if someone needs that, I can put it somewhere, like comment it on the Fauna and Flora post or something like that. Okay, so the highlighted green bits, those ones are the native bees that have been here since sort of those families have been living in Australia since the time of the dinosaurs. Because the bees evolved during sort of like the early to mid Cretaceous period, when South America, Antarctica, and Australia were still all joined together, and they slowly made their way across. And this small family has made a very big impact on Australia, like the plants around Australia, because they've evolved alongside them for so long without much competition at all. Because besides one group, which is Exonera, and I'll explain that one later, every single other bee family that isn't highlighted in green only arrived in Australia about 5 to 10 million years ago, when Australia moved north enough that the bees from Southeast Asia moved into Australia. And so because of that, they have different sort of plant preferences and sort of where they live and things like that. It's sort of determined more from bees that sort of have adapted to the tropics and then have sort of adapted out from the tropics, rather than these guys who have always lived within Australia. Okay, so there's short-tongue bees and long-tongue bees. It's a matter of sort of what is it? Mechanics. Even though in the middle column you can see that they do seem to have a pretty long tongue. It's like their tongue is actually on an arm that sort of levers out, and that allows them to reach deeper plants compared to green sort of ancient Australian bees, which are relatively shorter tongues, who sort of can't get into all the really deep flowers, which is very common in exotic plants, for example. And then on the far right, those are the long-tongue bees. So there's Exonera on top, and there's Amegilla on the bottom. I couldn't find a photo of Amegilla's tongue, unfortunately, but you can see the big proboscis, and the tongue sticks out from the bottom of that. So because of that long proboscis that it usually tucks underneath its chin when flying, it can reach very deep into plants compared to our short-tongued bees. Okay, so This was the title image that I made from the image from the what is it that I used to sort of put this all together. So we've got Hylaeus spider tuft on the left, and she is currently feeding from a Banksia serrata cone, an old man Banksia. Then we've got a Varroa, who is, we can't identify the species because they all look the same. And without a microscope, you don't really have much hope, unfortunately, for most of their species. And that one is on Poliscius semplififolia, which is very, very popular with native bees. Then we've got Ixonera on some platysash, and unfortunately, I forgot which species it was, but I think there's 3 species in Sydney. Or is there 3 species in Oatley? Sorry. Either way, that one's also a pretty common bush that the native bees quite like. And then the last one is Lepotricae spinaeru, and she's on Besaria spinosa, or Australian blackthorn. And that one's, the 2 that I found had so many native bees and wasps on it. It's quite really cool to see, but unfortunately, a lot of our flowers tend to flower pretty quickly and then they stop. So it's quite difficult to sort of see them sometimes. Um, anyway, so Hylaeus and Leucoptis, those are from our sort of ancient Australian bee families. Exonera, from DNA studies, they found that actually from about 40 to 45 million years ago, that bee arrived from Africa somehow. We don't know exactly how, and people have been sort of proposing things. And it might have sort of like, it's one of those bees that nests in vegetation. So it could have blown over here in like a storm all the way across the ocean. But it doesn't explain the fact that there is an African bee family that at this exact same time moved over there from Australia. It was a very long way away, and we know that they didn't arrive earlier because India didn't have any bees on it until it reached Asia, I think like 40 million years ago or something. So at that time, it was just too early for there to be some sort of land bridge or something between Australia and Africa. So anyway, that's interesting. They're still doing some research on that. And then the last one is the Lepotricae, and that one's one of the sort of newer bee families that has arrived in Australia. Okay, so the hard bit about identifying bees is that there's so much variety in appearance that it makes it very difficult to sort of figure out by sight what is a bee. But the important thing is that almost every single one of our native bee species tend to live either solitary or communal lives. They do not make any honey at all. They gather the nectar and they gather the pollen to feed themselves, and they sort of make it to feed their own kids, but they don't actually have like a shared, what is it? They don't have like a queen who lays eggs and then workers who assist. There's only 11 species in Australia at the moment, out of an estimated 2,000 that actually live in hives and produce any honey. In Sydney, we've got 1, and unfortunately, we live too far south for them to produce any honey commercially, because if you take any honey from them, there's a good chance the hive wouldn't survive winter because they don't have enough food stores to keep going. Okay, so on the left, we've got some variety of bees shapes, and the right ones are not bees. So we've got a Coronidid wasp, we've got a sawfly, we've got a mud bobble wasp, and we've got 3 different flies. And this is very magnified because most of these are only about 10 millimeters or so, or less, except for the teddy bear bee. That one's a bit bigger. But most of them tend to be pretty small, most of the flying insects. And that makes it quite difficult to sort of tell. But hopefully by the end of this, you'll understand that I don't think it's as in, what is it? It's like that distinction is not as important because if you sort of encourage the right conditions, there's a lot of good beneficial insects will come and the bees will come as well. Okay, so a lot of our native bees carry their pollen on scopa, but they carry dry pollen. So you can see on the top is it's one of the Leptopsis species. And on the left, you can see that she's got some like thick yellowish hair on her femur and just a bit on the thigh, as well as a little bit underneath her. And on the right, you can see her a same bee of that species completely loaded with pollen. It's pretty cool, like when they're that sort of rich with pollen. And different species carry their pollen in different spots. So there's a few underneath at the bottom. So like on the far right, you can see that that one doesn't carry any pollen on the legs at all. Whereas on the left, far left, it's a mix. And the one in the middle, sorry, the second one from the left, that one carries almost all of it underneath. But the problem is half the it's like half the bees are male bees and they don't have scopa. And a lot of our all of our native bees also don't carry pollen on scopa because they sort of eat it and then they carry it in their crop to regurgitate back at the burrow. So this is a range of native bees, and these ones are all male. So you can see a few sort of similarities between them. Some of them have longer antennae than normal, and they generally have hairless legs. But that's not 100% because some of the native bees some of the native bee males do look like they've got like hairy legs, but those aren't pollen carrying hairs, so they're different. You can sort of with a bit of experience, you can sort of tell them apart from the females. But part of the other problem is that besides like the far right, the Hylaeus bee species, which have got unique face masks, a lot of them look like not all of them can be matched with a female, unfortunately, not by sight anyway. You can do like a microscope analysis, but yeah, quite difficult. So we'll just sort of leave it in sort of like family groups or genus level analysis, and that's okay. Okay, so here's some of the male and female bees put together, and you can see they can look quite different. Like the Apotricase Varroa looks like it's a different color, even though he's got similar stripes. He's got different legs. For the blue-banded bee, Amygdala etc., the main difference is that the female has got the 2 dark stripes on her face, but the male's got very little on his face. And generally speaking, for the Hylaeus species, the males have got like more yellow comparatively. Lastly, Blossom for Australia is a weird one because that one's a wasp mimic and it's pretending to be a wasp. And it even carries its wing exactly like a wasp just to sort of sell the story. The markings are very similar to a wasp of that sort of shape and size as well, but with a bit of practice, you can actually tell them apart by eye without too much difficulty. Although they are only about 10 millimeters long, so it's still pretty difficult. Here's what the male bees do, though. So the male bees, they play an important role in that, what is it? The male bees won't be collecting any pollen because they don't play any role in the sort of childbearing, child rearing and all that. Their only goal in life is basically to mate with a girl. And to do that, they will sort of either patrol where the burrows are, so to catch a female as soon as she's sort of coming out for the very first time into the air, or they patrol the plants where the girls will likely to be. And I think the I think that also plays a role as well because of how much they move. Like the males rarely ever stop. Like if you're observing the same male, you can often see them like flying the exact same path every like 5 minutes. You'll see it flying around the plant, and it'll come back 5 minutes later, and it might stop every like half an hour thing just to take a quick sip of the flower, and then flies off again until later in the day when all the girls have gone home to sort of take care of the kids. But because of that, they can sort of, what is it? They can get eaten by other things, which are hunting things on the flowers instead of the girls, which are important because sort of like if because they're solitary bees, if the girl dies, then she can't pass on her genes. And so if the boy dies, well, there's it's not as big of a problem for the sort of species. And so I suspect it's something to do with like, the if they get eaten, then the girls are fine. The bottom left one, there's a assassin bug that caught a female of that species, and I managed to catch that boy checking out if that girl was still okay. But fortunately, very dead by that point. The right male got caught by a crab spider on the flower. It was really interesting because I saw it like walk right by the spider. It didn't see it at all. Like it just walked around the flower for a bit. Didn't see it. It did escape though. And in this image, it's actually trying to like push his abdomen towards the spider, and I think the spider let go because of that. Um, Male bees cannot sting, however. None of the male bees can sting because the sting is a modified egg laying bit, so only the girls have it. Yep, so here's some examples of some bee homes. Um, the top two on the top left, those ones are nesting in sort of like sandy, clayey, open area, and they sort of nest in holes. So if you're very patient and you know where they are, you can see them poking their head out. They're very cute. The top left one is actually so small, you can see those sand grains are the size of boulders. The top right one, that one's nesting in a cavity inside a clay embankment. And bugger, I forgot to fix up that bottom right one in that image. She's actually, sorry, that one's a super close up. I forgot to fix up that one. She's actually on a fallen tree. The tree was about 70 centimeters or so wide, very chunky. but some of our bees will dig into those fallen tree trunks to make their nest in. And that's why it's important that we keep some of those around because that's habitat for other insects. If you sort of um, take it all the fallen trees for like firewood or things like that, unfortunately, it just means that there's a lot less living spaces for these guys. Um, the one in the bottom middle, that one is actually it's a hidden burrow. So even though the sand looks flat on top, she must have poked something and the top like fell away. And she crawled in and then she filled it up. So it acted like a little like hidden entrance. Very smart. And then on the bottom left is it's a big human-made bee hotel. So those ones are these bees will nest in like pre-existing burrows or in vegetation that they can chew out. And so as part of sort of replacing that, we can sort of help them along. But unfortunately, that doesn't help most of the other species which can't live in existing burrows. And in Australia, I think the estimated amount is like 70% of our native bees need something other than like vegetation or that sort of reedy or bamboo hollows for their houses. Here's a bit more. The top left one, she's one of the species that doesn't have a guard bee. So in the previous slide, the top two, the top left and the top middle, those ones are guard bees. So they stay at the entrance of the burrow for all their friends. And so while everyone else sort of like prepares prepares things for their kids, they sort of sacrifice themselves and for the greater good for the whole group. And they will sit there basically all the time, guarding it. And if a bee comes, they sort of back down into the ground, into a little sort of room, and then the entering bee enters the rest of the burrow area, and they go straight back to the top again. So if you're lucky, you can sometimes see them either using their bottom to block the door to stop anything else from getting in, or you can just see the antennae poking out from the top of the little mound that they've left behind. It is quite difficult sometimes, like the bottom left as well. You can sort of see like this tiny little antennae poking out. But once you sort of like see the patterns of where they live, you can sort of see a bit more. Because it took me months to find them reliably. Because before that, I could only see them when they flew into it. But I've gotten to the point where I can see quite a few of them, even just walking around now. So hopefully we'll find more this year. And then the bottom middle and the bottom right, those are two bees that are nesting in sort of someone else has dug the hole and they just moved in after it's been left behind. And with those bees, you usually won't see them poking their head out, unfortunately, but you'll see them going in and out. I was just lucky to catch these two with the heads out. Here's an example of a slightly bigger bee. This one's about 10 millimeters long. And you can see how her head fills up most of the hole. It's a very nice, neat, round hole. But when the light is exactly right, you can see the face and the antennae about a few millimeters into the hole. I mean, it's still pretty deep relative to the bee size, but it's actually really tiny, like to our eyes. So it's quite a challenge. And you can sort of see her guarding it from ants. Those are the Iridomimex ants, the meat ants. And she's trying to like stop them from investigating her little burrow, protecting the rest of her family that's inside. Okay. As part of what is it? So our native bees, they are one part, but they're sort of like the cornerstone of a whole bunch of insects. So all of these use bee nests as a resource. So they use bee babies to sort of to feed their kids, basically. So we've got the velvet ants, we've got the carrot wasps, we've got the bee flies, we've got the cuckoo bees, cloak and dagger bees. Don't know exactly why they call it cloak and dagger bees. And we've got the cuckoo wasps. I thought the cuckoo wasps are sort of, I think they prefer more wasps, but they will, from what I've seen, they do investigate bee burrows. I just don't know the success rate. But all of these will sort of use bees to sort of get more to sort of what is it, to maintain their level of population. So when there's lots and lots of bees in the environment, you have lots of other insects using them as a resource as well. So these are all the velvet ants that I found within the park. Unfortunately, they're not very well studied in Australia, so there's a lot of unknowns. But I just separated them by appearance and their shape and size and sort of their markings. So, and then on the right, those are the males. And the males, so the males are flying around looking for the girls, and the females are trying to look into burrows so they can lay their eggs where a wasp has built its nest. They look like, what is it? They're ant mimics because ants are scary, like no one wants to deal with ants. So they pretend to be ants, but with a bit of practice, you can see that they don't share like the same legs. The sort of in ants, there's an extra body segment that's added between the second and third segment of these wasps, and the antennae are not elbowed. So in Oatley Park, there's a lot of flying insects around. And one of the most common on the hottest days of summer are velvet ant males. They act like they're just constantly searching for something. And that is because they use their smell to find, like their smelling sensors, to try and find the female. And they're pretty bad at finding them, but the girls are also very sneaky and very quick. And the girls like to hide underneath things, which was why it took me like quite a while before I got my first velvet ant photo. But now that I can recognize them out from like dozens of ants around them, it makes it a bit easier. But without practice, that's not easy at all, especially because the smallest velvet ant I found was about 3 millimeters, and the maximum is about 10 millimeters. But here's some of the velvet ants I in a single shot, and they were flying around like mad, just like trying to investigate everything because there was a girl hiding under one of the leaves, and I managed to catch her as she was just running out. None of the boys found her. I don't, unfortunately, because the boys and girls still look a bit different. We don't like you can't really match species, but you could just know that there's a lot of the different ones around, and they're quite active. Like you can see quite a lot of them around once you sort of know what to look for. Another one of the major parasitoids of bees is bee flies. And in Oatley, I found one tribe and 7 genera. So because I asked an expert, and it's because that one tribe has got a few different genera in it, and you can't identify them except with a microscope to like tell which one. So they all get lumped into that one tribe. It's that stripy one on the bottom, right? There's a whole bunch of stripy ones that look very similar. And fortunately, yeah, it's just a issue when like, what is it? A lot of the time, insects are characterized by very, very fine details that you can only get with a microscope and a dead specimen. And it's pretty cool anyway to see all the different ones that we've got. But the interesting thing about them is that you can often find them, the females, dragging their bottoms on the sandy ground. And that's because, and then when they fly, sometimes you can, if you get a photo of it anyway, there's a bit of sand that's stuck on it. It's because that's where their eggs are very sticky. And they coat their eggs with sand, and then they either lay the eggs or they drop it or they bomb it. They flick it into a burrow so that when the baby hatches, it will run to the sort of like the larvae of the wasp or the bee that's there. So the fact that we've got so many of them is a good sign because it means that there's a lot of wasps around that are nesting and a lot of wasps that are sustaining this sort of population. Anyway, we know that they eat pollen because I caught one. But what is it? Sorry, we already knew that, but I was lucky enough to catch one of them eating pollen by sort of like dapping its hand down on the banksia and then flying back up and then eating it, licking it from its hand. That's pretty cool. So, okay. So what can we do to help with our native bees? Part of the problem is that like it's a mixture of the different types of flowers that are in the environment because a lot of the native plants that bees like, they're not very pretty plants. They're like scraggly or they're not decorative. And a lot of the sort of really pretty flowers tend to be aimed at birds and not insects. And that's partially why we've got a noisy miner problem, but that's a completely different issue. If you're interested, you can ask me, but won't be talking about that. We can make bee hotels from we can make them out of clay to help Amagilla and other like ground nesting bees that sort of like dig in horizontally into space. And we can also make bee hotels made of reeds, bamboo, like hardwood for some bee species. Unfortunately, a lot of our bee species actually need bare ground. So no grass, no mulch, none of that sort of thing. And that is the reason why Oatley Park is very popular with our native bees because of the tracks where the plants are growing and the bees nest on the track. So there's a pretty good chance if you walked around Oatley Park, you stepped over a bee nest or stepped onto a bee mound. They will dig themselves out. They're fine. It's not a problem for them. But it's sort of like that sort of environment is unfortunately not favored in sort of human designed gardens or like council green spaces. We don't have very much of that sort of bare ground that's well drained that our bees can actually use. So that's part of the reason why the numbers are not very high. And the other issue also was that European honeybees are unfortunately really rough for our native bees because they start earlier in the season. They start early in the day because they're bigger. They live communally, so they can sort of maintain a higher temperature inside their hive. Whereas our native bees need the sunlight to sort of warm up the ground enough so that if it's not warm enough, they don't fly, or their adults don't grow up and come out. And so European honeybees are sort of like they're 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 essentially livestock bred to hoard honey. Sorry, bred to hoard nectar to make honey. And that means that there is much less resources available for all the other insects that need that nectar to feed on and to grow. But we can at least help them by making some human-made bee hotels. Its positioning can be quite difficult because, like even inside the park, there's like it might look like a good spot, but like one spot has like 100 bee burrows, and then you walk 20 meters that way and there's nothing. So bees can be pretty picky until it gets to later in the season when all the good spots are taken, and then they start finding some weird spots. But it's also like they use more holes in trees and old reeds and things like that. And it's important for us to sort of be aware that that is an environment that bees can live in. But we can sort of help at least some of them out by providing them like a human-made home. And with a bit of trial and error, you can find the right spot. And that also brings in a whole bunch of like friendly wasps as well, like the ones that hunt for like little spiders, or some of them will hunt aphids, some of them will hunt like cockroaches, things like that. And they also will also live inside a bee hotel. So when you've got sort of like a nice ecosystem, you'll have native bees as well as some sort of like pest control as well. So yeah, just to finish up, some of the bee books that I found, this is really nice. Terry Houston's book. It's got a bit of, it does go into a fair bit of detail, but not nearly as much detail as Jacoby's new book, which is basically has a chapter on every single genus, and including all the research, and like refers to all the different papers and identification keys and all that sort of stuff. So, and has a lot of photos as well. And that was just released last year, at the end of last year. Very good book, and I got it for $40, which is pretty good. And this book I quite like as well, for plants. Then by Alan Fairley and Philip Moore, Native Plants of Sydney region. It's got lots of photos of different flowers, nice amount of information, but you sort of have to use it in combination with the bee books. And the last one is there's an annotated, it's a guide, it's a key to help you identify what type of bee if you've got a photo of it. Unfortunately, that booklet is really designed for samples, but like as in like dead bees that have been preserved. So not as useful if you've only got like a little like your phone camera or something like that, but it does give you a bit of information here. So that was it. Thank you. I hope you enjoyed it. There was a lot of information in it.
Wow, Nikki, that was interesting. There's so much of another world out there. We've got time for a few questions. Anyone on Zoom can put up their hand, or any questions in the audience, just pop your hand up. Yeah. Would you like to come out?
Thanks, Nikki. Once or twice during the talk, you spoke about during the season.
Yes.
So I assume you're talking about the predominant flowering season, late winter through spring, or are you talking about through the warmer months?
That's the difficult thing. So I didn't want to go too deep into this because it's a it depends question, because we've got so many bees. Some of them go for certain flowers, and so if it's a specialized bee, it only like those plants only flower at a certain time. So they might have like one generation a year when that plant flowers, and that's it. And then the babies like hibernate until next year. Some of them might have 3 or 4 generations in a year, depending on like how warm it is and the availability of the flowers that they're able to sort of get, and if there's enough like nesting space. Some of them might have 2 generations a year. It all depends, unfortunately. Generally speaking, it's the quietest between like April and late July, early August. That's the quietest time because that's too cold. It's a bit too cold for bees overnight. I did find a few bees here and there, but yeah, they're pretty rare. Whereas in like the peak in summer, you could like stop by a single bush and see like 2, 3 dozen bees just like flying around foraging from a single plant. So
Debbie, I think you
Yeah.
had a question too.
You're talking about the temperature
yes,
and the temperature that the bees and food will be active. So are they active? Can they be active on just a warm day in a cool month, or do they hibernate, or say, or die out, and then so they have to have many warm days to be active?
yeah. So that one is also a pretty complicated one because some of them seem to be more like cold tolerant than others. Like there is a bee that I'm looking for at the moment that's it's called Trichocoletes, and it's known to be coming out pretty much as soon as like as early as mid-July. And they don't sort of you only see one generation of them. So once it hits about like early spring, they all die out and you won't see them until the next year. 18 degrees Celsius on a nice like cloudless day is when you'll see like the stingless bees flying out, which is why like in Sydney, yeah, they don't fly out enough during winter to forage and sort of keep enough nectar for their hives, so you can't harvest any. But yeah, like the hotter the day, I find the bees are still pretty active. But the thing is that in Oatley Park, because there are so many like other things that are targeting bee burrows, as you can see, like all the bee flies and the velvet ants and all that. I found that in Oatley Park, the girls would forage early in the morning, so like about 10 o'clock to about maybe like 12, 1 o'clock. But as soon as it got to the hottest part of the day when the wasps are the most active, they went back home to protect the nests. Whereas in other places where they don't have as much pressure on them, they seem to forage a bit later into the day. And in the afternoon, you only see the boys foraging usually. But it sort of depends.
Adrian.
Nikki, regarding the bee honeybee,
Yes.
how effective are they? Do you see the real need for them?
I think they're really important because it's filling a gap that, what is it? We have like our suburban gardens can have ornamental plants, but those ornamental plants are not very good at providing the habitat that the reed burrowing bees and vegetation burrowing bees need to actually make a nest. And so we sort of need to make one for them. As for like the clay option, it's because Yeah, it's like the clay embankments are all cleared away. Unfortunately, they often get like bulldozed to build a house or build a retaining wall or something like that. And that means that the bees can't live in that spot they used to. And those spots often are sort of like considered, they seem to be sort of considered less important or like sort of like, there's like, it seems that some people think like you can do something better with that spot. But they're not sort of like not aware of what things actually utilize those sort of environments that unfortunately a lot of human activity and gardening and stuff like that has cleared away. So what we're doing is actually, if we don't provide those spaces, we won't find native bees. And if you do find native bees in your area, it's probably because one of your neighbors relatively close by has them. Because while European honeybees can travel like 5 kilometers to forage, it's way less than that. I think it's like probably like 500 meters or so for native bees or less. Because often like I would watch a plant and I would see a same female return every like 5 or 10 minutes. If that bee is only like 5 to 10 millimeters, how far do you think that she's getting from her home to back to the flower in 5 minutes? So like they don't travel very far. So yeah. If we don't provide enough houses like for our native bees, then you won't see as many of them, unfortunately. Were there any other
Thank you,
questions?
Sue.
Yeah. Okay, so an ant nest is so an ant nest and a bee nest are both cones, but a bee nest rises up vertically and then drops off. But an ant nest actually like curves outwards and looks like a volcano. It sort of like curves outwards and then it drops down. Whereas bees will be perfectly vertical all the way up to the top because that's how they protect their home. Because ants have got lots of other ants to protect them if something sort of like goes into their burrow entrance, but those bees only have one bee to guard it. So it'll be like a straight up and then it falls off very sharply for a bee. But if it goes up and then it curves out and then drops off, then that's an ant. We do have other bees, sorry, we do have some other like bee nests, like some bees don't actually leave a mound because they're smart and they pick up the bit and they drop it off somewhere else to hide the fact that there's something living there. Because they rely on that obscurity to sort of protect their homes. Whereas some bees will have that guard inside that little central column, so they don't care as much.
Any questions on Zoom, Kim?
I think so.
Any other questions here? Maybe one more? You've had a go.
How long have you actually been studying birds?
Since October. I started completely from scratch.
Maybe how many hours have you been studying?
I've lost count. Like just in the field, I think I logged over 300 hours just in Oatley Park. That it's been a long time. So that doesn't include any of like editing the photos. I think I uploaded 6,500 photos to iNaturalist. And 2,000 of those are bees. So as you can imagine, trying to making some of the resources tonight was partly from my experience in sort of like remembering when I took certain things, but it was just like it gets quite a lot. Yeah.
What you use to explore?
Do we have internet on this? Might be easier to show you. I'm naturalist. Let's see, we can, if we go to iNaturalist and we search up Oatley. Oh, sorry, I need to change the thing. How do you change the window? One sec. I think we just need to stop this. Stop the presentation. Okay.
Your fire needs a stir.
Share.
Fire's going out.
Oh,
Have a good sleep.
someone's not muted. Is that working? Sorry, how do I activate the screen share for this? Sorry. I'm trying to screen share.
Click on share. And what?
This one. It's and then it's because it's not on. Is it because it's on a different screen? Sorry about this.
Stop the other one.
I think it's because it needs it's because on a separate. There we go. It's on a separate. Okay, I got this. Oatley. Save. Oh. Is it on a separate? Oh, there it is. Found it. Got it. Okay. Sorry about that. Let's see. It's trying to figure out where all my different things are. Same time. So that is all of the 1800 observations I've added on iNaturalist. As you can see, I've covered up most of it. I haven't done that much into the golf course area, and I haven't done as much around the front oval. But I would consider that I've covered a fair bit of ground. I have not left off any tracks. Everything has been on the track. Oh, yeah. So this is all, I've not left the form tracks. For pretty much any of that. So that's, you can sort of see, you follow the lines. I haven't marked the sort of like locations of some things exactly, like for burrows and things like that. But you can see. Sorry, trying to. Function. Listen. There we go.
Right, the
Yeah.
good news
There we go.
is that, the August walks will be hosted by Nikki. The August walks will be hosted by Nikki. And, Nikki has volunteered to take small groups of interested people on a personal insect tour of Oatley. Now, how often do you get into like that? So all those places might come to us. And Nikki is here, will be your guide.
Yeah, when
People might be interested in that.
I've given 3 dates for this. It is it's the 18th, the 20th, and the 23rd.
Okay, so if you're interested, how many, what's the maximum number?
Maximum 6.
Maximum 6 in each group. So maybe
And if we're booked out really quick, I might offer
Yeah.
that Sunday.
well, there we go. So if you'd like to come at the end of the meeting and just put your name down for one of those days, that'd be great.
Yep.
So Nikki, I'm going to call up Debbie to give you a thanks talk.
Well, thanks, Nikki, and congratulations. It's an amazing study you've done, incredible amount of work. And I think you've pointed out to us that the amazing biodiversity of Oatley Park and what you see when you start to look closely. Now, anything about nature, it's about the more that you look, the more that you see, and that you're contributing to our understanding and knowledge about the wildlife. And it's a fascinating topic, and I love seeing them in my garden, and I'm just hoping I can encourage more of them. So we just like to thank you with this calendar that we've decided to produce.
I hope everyone learned a lot.
We have no photographs of bees in the calendar as yet, so maybe next edition.
Maybe